All right. Good morning, Shepherd. How are you doing? Um, Welcome back to week two of remote learning. Want to continue what we were working on last week. This is kind of an extension of molecular empirical formulas. And so we've got a little bit of work to do. We're actually going to look at how to go from the empirical formula into the molecular formula, okay? So I'm going to walk you through this. So before we do that, let's first review empirical molecular formula real quick, okay? So the empirical formula and the molecular formula are related, okay? The empirical formula is the simplified version. So I'm actually going to skip down to this one right here, phosphorus oxide. We see the empirical formula here is P2O4, okay? So this is the simplest ratio. Over here, this is the molecular. So this is how it actually exists in nature, all right? So this is the actual molecule is P4O8. It's actually more complicated than the basic reduced version of it, okay? So what we're going to be talking today is how do I go from the empirical formula and get the molecular formula. Before we do that, though, I want to look at how many times bigger a molecular formula could be compared to empirical formula. Now, it can be lots of different times. Okay, 1, 2, 3, 4, 5. Usually doesn't get that much bigger than that. With some of the things, like some of the sugars, you'll see that. But typically, you're going to be having a molecular formula that is 1, 2, or 2, 3, or 4 times bigger than the empirical. Okay, so let's take a look at the first two here, CO2 and CO2. The reason why I put this on here is because sometimes they are exactly the same. So it is no times bigger, okay, or it's a 1x of its original. Same thing with this second one, okay? So we can think of these as multipliers. These are the same, these are the same, therefore my multiplier in this case would be 1x. And the multiplier thing will become a little bit clear as we work through this to the end. Now if I look at this one, okay, I've got C2H5 and C4H10. I would actually need to multiply my empirical formula by 2 in order to get the molecular formula, okay? So how many times larger? It is 2 times larger, okay? If I look at the second one here, or this one here, P2O4, P4O8, I would need to multiply the empirical formula by 2 to get the molecular formula, okay? So that would be 2 times greater. The last one down here is CH for the empirical, and our molecular formula is C6H6, my molecular, okay? So I'm going to multiply the empirical by 6 to get the molecular. So my multiplier, it would be to a magnitude of 6 times, okay? So I want you to keep that in mind as I show you how to do the next part. Because what we're going to do in the next part is we're going to calculate, I'm going to show you how to calculate how many times bigger the molecular formula is than the empirical formula. It's real simple. Okay? So here is the formula we're going to use. Okay? So this multiplier, or how many times greater the molecular formula is to the empirical formula, I get if I take the molecular or the molar mass, okay, we've been calling it the molar mass, or MM, and divide it by the empirical molar mass, okay? So this is the mass of the molecule, this is the mass of the empirical formula. Now, so you're not confused, the molecular molar mass, okay, this is the molar mass that is given. Okay, so everything we've been calculated on the next worksheet when it says molecular mass or molar mass, that is the molar mass that we've been using. Empirical mass is going to be something we calculate off of this. All right, so let's keep those two things straight, and that's going to give it this n, which is our multiplier. Okay, and then our molecular formula will equal our empirical formula multiplied by our n value. Okay, if that was confusing, let's try a problem, walk you through it. Okay, so here's example number 1. Okay, now I'm going to rewrite a couple things on here so that we have it for reference. Okay, you might want to do the same. Okay, and you're going to start seeing me do some shorthand here as well. Um, Molecular formula, we're going to start using MF. The empirical formula will be EF, just because it takes a really long time to write those two. So whenever you see those, specifically when we are circling an answer and identifying it as one of the two, okay, you'll see MF or EF on there. Okay, so first things first. This problem, now, in order to get the molecular formula, okay, we first need to look at the empirical formula and determine its multiplier. All right. From that, what we're going to do is this. I need to know the molar mass of the molecular formula, and I need to determine the empirical mass of the empirical formula. So this here is 345.82 grams. This is our molar mass. Right, so that's going to be our first number that goes on top here. All right, so I'm going to identify this as my molar mass. That's going to go up here. So N equals 345.82. And it makes sense that this is going to go on top because the empirical formula is smaller than the molecular formula. So we're going to have the larger value on top. We're going to divide it by the lower value on the bottom. Right, so 345.82 grams, that is my molar mass or molecular mass. Now, I need to calculate what is my empirical mass. From the prep, they say the empirical formula is P2O5. All right, so I have 2 phosphorus and I have 5 oxygens. I'm going to use my periodic table on my big sheet, okay, and phosphorus is 30.97. Oxygen, 16.00. Multiply these through. There we go. Okay, and this equals my empirical mass. Okay, so we have two things going on here. First of all, they give us the molar mass, which is the molecular formula. We need to know the empirical mass, and they gave us the empirical formula right here. So we are going to add up the empirical mass, all right, and we're going to divide the molecular mass by the empirical mass. Right, and when we do that, that gives us a value of 2.0115. Now, as long as we keep this as a 0, this is close enough to 2 to say that we need a multiplier of 2. Okay? So this is my n value. So what I'm going to do now is I'm going to take P2O5 and multiply it by n. Okay? So P2O5, this is right here, this is the empirical formula. I'm going to multiply it by the 2. That will give me P4O10, and this is my molecular formula. Okay? So I'm using the molar mass divided by the empirical mass to tell me what my multiplier is. And then I'm going to take the empirical formula, multiply by that, okay, in this case it was 2, and that will give me the molecular formula, okay? So if that was quick, okay, you can go ahead and watch it again. I'm also going to do the next one here, okay, and this one is set up just a little bit different, okay, because you notice it gives me the percentages, okay, and it's asking me to calculate the molecular formula. So question mark, molecular formula, they give the molar mass, okay, and I'm just going to set the separate here, so my n, my multiplier, will equal, okay, my molar mass over my empirical mass, and I already have the top one, so I'm going to put 216.04 grams right there. So really what I know I need to do is I need to know what is the empirical mass that goes down here, okay? So this is a question mark here so that I can then calculate the n. All right, so how do I do this? This one's set up differently because instead of giving me the empirical formula, they're giving me all these percentages, okay? So the thing I need to do first is find the empirical formula. Okay, so this is a review. This is what we're carrying forward from the last homework. So if you didn't do the last homework, go back and do that. Okay, you won't be able to do this without having done the last work. All right, so I've got 25.93% nitrogen and 74.06% oxygen. So I'm going to take this and translate it into grams. Okay, remember, if I've got these as percentages, I'm going to take it out of a 100-gram sample, okay, and that will allow me to determine my ratios. So this is for nitrogen, and oxygen is 74.06 grams. Okay, now I'm going to divide this by the atomic mass of nitrogen, so that's 14.01, and that will give me 1.85. And I'm going to divide my mass of given oxygen by its molar mass. And that will give me 4.629. Okay, and these are actually moles. Right? Once I have that, I have my molar ratio. Notice they are not whole numbers, and this is not close enough to a whole number to be able to round it. Okay? If you're going to round this, it better be something like 1.99901 or something like that. Okay, real close. This is not close enough. So I'm going to take this and divide it by itself, and I'm also going to divide this by itself as well. So this gives me 1, and this one here gives me 2.5. So right now, I have an empirical formula of N1O2.5. This won't work because we can't have a half atom of something, okay? So I'm going to multiply this to get these into integers. So I'm going to take this, multiply it by 2, and I get N2O5. This is my empirical formula, okay? I'm going to put a box around it. All right, if that's my empirical formula, what I need to do now is calculate what is my empirical mass. All right, so I've got N, I've got 2 of those, times 14.01, and I've got oxygen, I've got 6 of them, and 28.02, 80, total them up, and I get 108.01. Okay? So this is my empirical mass. That's going to go right here. All right, so I'm going to put this right down here. So the nice thing about this, I don't even have to use your calculator. Okay? 216 divided by 108 gives me 2. All right? So I've already done my empirical formula. My molecular formula is going to be 2 times the size. All right? So I'm going to take this and multiply everything by 2, leaving me with N4O10. This is my molecular formula. Put a nice box around it. Okay? So there you go. There's the work for these problems. Okay? Try out a few and see how it goes.